All right, just like before, we're dealing with a situation where we've already got the y isolated in one of the equations, which makes this really convenient for solving. So I'm gonna write the two equations here on number 14. Actually, I'm going to write the second equation that we're going to substitute in. I'm going to say 7, oops, well, that's weird, didn't expect that. 7 equals 2 minus y. And I'm going to zoom in here. You can see that y is equal to x minus, or 8 minus x. So I can say 7 is equal to 2 minus what? 8 minus x. That's what y is equal to, so we can put it in wherever we see y. And now we just have to resolve this. We say 7 equals 2, and I'm going to distribute this negative. You see a negative out front of parentheses with nothing else in between it, just minus and then the parentheses. That means you're subtracting everything inside, and everything inside will have its sign changed in order to free it out of the parentheses. So negative times 8 is negative 8. Negative times negative 8, negative times negative x, this right here, is actually positive x plus x. And then now we're simplifying. 7 equals 2 minus 8 is negative 6 plus x. And when I add 6 to both sides, I get 13 equals x. That's solved for x. Now, I'm going to take the other equation. Y is equal to 8 minus x. And I know what x is, so now I'm going to say y is equal to 8 minus parentheses, what? 13. And I get y equals negative 5. So we have as a solution 13, comma, negative 5. Be sure that you get them in the right position, x in the x position and y in the y position. Okay? And now we're going to test both equations out to see if it works. Y equals 8 minus x and 7 equals 2 minus y. Okay? Something seems funny. You know what's funny to me? I was looking at this and I couldn't figure out what's funny, is that this equation, although we did solve this just fine, but this equation already only has a single variable, so we could have actually just solved that for y immediately. And so I'm actually going to do that over here on the side, just like actually really zoomed in and really small, okay? I'll do it in blue. If you have 7 equals 2 minus y, I should have noticed this, I can say minus 2, and we get 5 equals negative y. Dividing both sides by negative 1, we get negative 5 equals y. And I actually didn't need the other equation to do that. See that? So I should have noticed that there's only one variable in there and we didn't need to actually substitute that in. Yep. So anyway, we did it. So I'm going to erase that and we'll just finish this out like normal. So sorry about that. Doesn't mean that it's an error. I just kind of didn't need to make it quite so complicated. Okay. Oops. Okay, now I substitute in for y. Oops. And I substitute in for x. Over here, I substitute in for y. So what does x equal? We found that x equals 13. What does y equal? We found out that y is negative 5. Negative 5. And if we simplify both of these, we get negative 5 equals, what is 8 minus 13? It's negative 5. Check. And 7 equals 2 minus negative 5, which is the same as 2 plus 5. So then 7 equals 7. Check. Nice. Okay, we're going to do the same thing for this one now. Okay, we know what y is equal to. It's equal to negative 2x plus 6. So I'm going to write this first equation, 3y minus x plus 3 equals 0. And I'm going to substitute in y with 3 parentheses. And what does y equal? Negative 2x plus 6. So when we distribute that through, we get negative 6x plus 18 minus x plus 3 equals 0. And the first thing I need to do to sort this out is to combine like terms. And I've got a negative 6x and a negative x. That becomes negative 7x plus, and here I've got 18 and 3. 18 and 3 is 21 equals 0. And I got to isolate the variable. I get negative 7x equals negative 21. And I need to divide by what's in front of the variable. And what's in front is negative 7. So we then get x equals 3. That's a partial solution because we still don't know what y is. But we can take the other equation, which is y equals negative 2x plus 6. And we can substitute in for x the value of x that we found it to be. And what do we find it to be? 3. Okay. So y equals negative 6 plus 6, or y equals 0. Nothing wrong with that. Y can be 0. So we have as a set of coordinates 3, 0. Okay, let's test it by writing the original equations. Y equals negative 2x plus 6 and 3y minus x plus 3 equals 0. Okay, we'll do these one at a time. We say y is equal to 0, x is equal to 3, and when we resolve that, we get 0. Oops. Zero equals negative 6 plus 6. 0 equals 0. Check. Over here, we've got 3 parentheses minus parentheses plus 3 equals 0. And we know that y is equal to 0 and x is equal to 3. So we get 3 times 0, 0, minus 3 plus 3 equals 0. 0 minus 3 is negative 3, plus 3 equals 0, and this is 0 equals 0. Also a check. So our two proofs worked out, and there's all the math. We are done. Actually, I probably should be writing up here proof. And same thing over here. Proof. Because just like the old school first semester stuff, we're doing a proof. So we should show it like that. Oops. Okay, there's all your math. Hopefully that makes sense to you. We're done.